just to actually introduce this playlist of videos that I'm going to make regarding meta-analysis. They're all going to be related to the same worked example and the same meta-analysis that I'm going to carry out. Now, why do I want to do this? Well, I was a university lecturer at various universities. I started at Exeter, went to statistics at Oxford, and finally I was at Westminster. And I did YouTube videos as part of my teaching, particularly as part of flipped learning. And some of the videos were about meta-analysis, and these were there to support final year projects and people who had to carry out meta-analysis. I was asked by a final year student from another university about how she should go about doing her meta-analysis. Now, this came about because she'd seen one of my YouTube videos. So she sent me an email to ask me, what should I do? So we had some email discussions and some online meetings, and she showed me the papers that she had. And I gave advice and went through the process. Now, because that person's doing their final year project, I don't want to tell them how to do their final year project, because this is an assessment. So in these videos, what I'm doing is giving the extra advice that I couldn't give when I was giving advice to a project student, and that people might find useful if they're actually carrying it out for themselves. So the reasons for creating this set of videos is to capture the advice, to improve on the advice. So I have changed some of my views and the ways I processed the data. Now I've had more time to look at it and spent more time looking at the data and thinking about it. It gives a working example of a typical student project, so what I would expect a student to do if they were completing their undergraduate project and they were doing a meta-analysis. It gives you a lot more in-depth look at the practicalities. So the videos that I've done before are largely somebody's collected a set of data, they give me the tabulated data. I might have to move it around a little bit to get it into the right columns, but they've extracted the data from the papers. In this case, I'm going to do the data extraction itself, and it's a lot harder than you think. So some of my colleagues get people to do meta-analysis and they're sitting there thinking, well, the student hasn't done very much. They've done a meta-analysis, they've only got 4 or 5 papers, maybe I want more analysis for them to justify them getting a good mark for their final year project. The reality is, an effective systematic review properly done with Prisma and then extracting the data with the correct design, that is more than enough for an undergraduate project without actually getting to the point of the meta-analysis. But because there's often a requirement as an undergraduate project to do original analysis, then the meta-analysis is often forced to be included. Data extraction is very difficult in some cases because of the problems of comparable studies and the differences in the design of experiments. Sometimes you need to use tools because they've only given it as graphs, they haven't actually given you tabulated data, and sometimes they report completely different measures to the ones you're expecting. It also emphasizes the need to really think about your data and the false beginnings and the tricks and problems that can happen when you're preparing your data. This means there are several traps you can fall into and mistakes you can make. And it also allows me to think more deeply about the process of meta-analysis for myself, in terms of the philosophy and implications. So I can think a bit more about the Bayesian way, because I've just finished reading a book called Bernoulli's Fallacy, and this has sort of inspired me into thinking again about the way I do things. What it isn't. So it isn't the complete and ready for publication meta-analysis. It's for demonstration purposes only, because I haven't done a full systematic review and I do not know that the literature has been covered perfectly. I have a list of papers, there will be others that are missing, and those missing ones could make a difference to what you conclude. I'm not going to cover the process of the systematic review or doing the Prisma guidelines. I assume that those have been done already, and that is a completely separate topic all on its own. To do that very well is a highly skilled and very involved problem, and not one that I wish to look at here because I'm just going to focus on the statistics. But you do need to keep in mind that the choices you make during that systematic review process and using the Prisma guidelines mean that regardless of everybody saying that a meta-analysis is the highest form of assessment, it forms the highest form of evidence, it's at the top of the pyramid of evidence, and it's completely objective, this is fundamentally not true. Nothing, no science ever is absolutely objective, because you make decisions about what you choose to do your studies on and how you choose to do them. So in Prisma, you choose what are your inclusion and exclusion criteria. Nothing can be objective, but so long as you declare all of the subjective things that are sitting behind it, I don't see that's a particular problem.